Okay, so now we are going to look at one example on the one sample t-test. So we have 10 individual had taken an exam, and we want to test whether their scores altogether are significantly different from the score of 100. So these 10 students took the exam, and after they took the exams, their average score was taken, and it was found to be 107.8, and that is the mean of the 10 individuals. So you see, one thing that we actually need to know here, we are talking about 10 individuals. It means that the number of individuals are 10. So we are not going to work with what you call Z statistic, because we are talking about 10 numbers of individual. And then the average score, which is the standard score, is 100. And this is what we obtain from the average mean score of the 10 students. And then now you now see the sample mean minus the standard mean, and then the standard deviation is 5.35. Of course, the number of samples is 10, so we have square root of 10, and at the end we have this value, which is 4.61. So when we are using t-tests, we usually refer to a t table and get our calculators and get our critical t value. So how do we get our critical t value? We must calculate the degrees of freedom. And the formula for calculating degrees of freedom is n minus 1. N indicates the number of sample, and of course the number of sample from our question is 10. So that is why we have 10 minus 1, and we have 9. And the confidence interval of this work, although it's not actually stated, so since the confidence interval is not stated, so let's assume is 95%. So that is why our now we have to refer to the t table to determine the critical t value for 9 degrees, which is this degree of freedom, at the 0.05 level of significance. So since here we have 0.05 level of significance, it tells us that our confidence interval is 95%. So now, how are we going to get this? So you see the degree of freedom is 9, and then the confidence interval is 0.05. So it means that we are now going to the table, look for the 9 under 0.05, and then you take the value, which will actually give us 2.26. So now let's go to the table and see. Let's go to the table and see. So this is our table. So we have, where do we have 9? Look at it, we have our 9 here. And we have 0.05, 0.01, 0.001. So of course, for 0.05, this is 9, and 0.05. So we have 2.262, which is our calculated t value. So our critical value. So now, how are we going to represent this on a table? It's simple. So in a diagram. So this is our normal distribution. And we have here is a rejection region, and we have our critical t value as 2.62. So you see, as you are moving, this is 2.62. So as you are moving, of course, this is the rejection region. If you could remember, this is the rejection region. So since this is our own rejection region, what are we going to do? So we have plus 2.64, but our calculated t value is 4.62. So sorry, 4.61. So it means that it will find, because this is usually the negative side, which is 2.62 is negative. So it will be moving, this is positive, so it will be moving this direction. Maybe here you have plus 3 0.62, then it will continue. So you see it falls within the rejection region. So that is to say, since our calculated t-value is this, so it's greater than the critical t-value of 2.6, so we can say that the score of our sample of 10 individuals differs significantly from the score of 100. It means that we are going to reject the null hypothesis, because the null hypothesis here in this calculation, it means that there is no difference between the score of 10 individual with that of the standard score of 100. Okay, so that is this.